All right, I think we should be live. Cool, I hope. Let's see how this goes. Okay. This is my first time doing a live where I'm actually doing it live, and I'm doing it through OBS, so I have no idea if this is working. If someone is watching, could you say something in the chat? I doubt anyone's watching. So, let's just assume it's working, and we'll keep going. All right, so this is the second week in Go Rust and doing a kind of a live coding exercise where I'm trying to learn Rust. And yeah, last week was an interesting week. We kind of went through the journey of using request library to do API stuff, and then doing kind of diving into derive and traits, and so that was interesting as well. This week, I figured let's start down the path of doing a little more with the Star Wars API and calling the API, and we'll start with doing different data types and kind of just see where everything goes from there. Last week, it just kind of flowed because of confusion with traits and derive and serde and all that stuff, and I kind of hope the same thing will happen this week and we can see where it goes. The first thing I intend to do is we'll do some data types that we can kind of pull down to with serde, and then once we do that, let's see where we go from there. So the first thing I want to do is let's actually switch over to our code, and there we go. So this is where we ended off last time. With our main function, we are getting a response, calling request.blocking, and we're getting the URL for a thing using serde JSON and getting the value of that so that we have a general output. So if we do cargo run, it's going to compile it again, and then it's going to give us an output that we expect. So in this case, it's doing a conversion into JSON and giving us what we want. Instead, we want to actually be able to use these objects in an expected manner. And so let's go ahead and define this as a struct. And since I have Copilot, and it should work, I've not used it in a Rust application, let's go ahead and copy this. This is how I use it. We'll paste. And then, all right, let's do struct starship. Then let's give it a second to try to figure out what it wants to do. Name, string, model, string, manufacturer, costing credit. Okay, this isn't doing what I was hoping it would. So in this case, I think a lot of it's just going to be string. Crew, passengers, and then cargo capacity. That should be it, URL. So that didn't actually work out as well as I was hoping it would. Let me show you an alternate way to do that if you don't have Copilot. Sometimes this will grab out exactly the way I want it to, and sometimes it won't. So let's go back over to here. Let's go to here. Let's see, can you give me a Rust struct based on this JSON? And boom. See, and this is one of the great things about it is I was just going through and I was doing, you know, with Copilot. In this case, it's giving me the serde derives as well. So let's go ahead and copy that. I think we'll go ahead and change and do this. What just happened? Okay. Going a little wild here. All right. Guess this is wanting, I should have snake case. Interesting. Okay, hold on. Okay. So we do a vector of strings. Serialize, deserialize. Let's see. Cannot find the derive macro deserialize in this scope. Deserialize is imported here, but it is only a trait without a derive macro. It's interesting. Yeah, that's what I expected. Note it didn't give us anything about the MGLT. I think this is just a, for now, just like a make it nice type thing. All right. So why serial is imported here? Cannot find derive macro in scope rust C. Do serde? Well, I mean, I should have, like, getting this error. Like, it just doesn't make sense because I have serde installed. Because serialized derive macro isn't being found. This usually happens when the derive feature of serde crate isn't enabled. Oh, interesting. That's something I wasn't aware of. So apparently you can set features and they're off by default, and we have to edit our cargo.toml. Did not know that. Now I know. Okay, so let's do this. $195, kill that, save, cargo build. Awesome, it's building. Okay, help convert the identity. So it's a warning, it's not. We can worry about that another time if we ever want to get to it even. So with that in mind, let's try this. Let's do no. Oh, crap. Let response equals request blocking get. Let's see what that does. So it's going to infer doing a result with starship or error. We're going to print response dot. Okay, okay. Convert self into, okay. So in this case, it's a result. Okay. Unwrap. Oops. I think is what I need. Is that it? There we go. Okay. So debug is there for unwrap. So if that's a debug thing, we need to figure out what to do in normal instances where we're not unwrapping the data. But that kind of makes sense. We're getting a result back. And we do want to get the data back. So let's go ahead and run this. Cargo run. We're going to get our normal thing. And there we go. There is our result. It's popping it out as a Starship struct. Everything. Oh, that's interesting. Pilots is not populated. Oh, an Imperial. Okay. I was looking at one point the Millennium Falcon. So let's change this to a 10. And cargo run. And there we go. We have our pilots. The light freighter, blah, blah, blah. We're good to go. Okay, so I mean, that was pretty simple in taking that JSON that we're aware of and converting it into a Starship struct. Save some typing by using AI, because that would be kind of annoying to go through there and try to actually, you know, one line at a time, type it all out. So that was nice. So as an interesting thing, let's do crew and passengers. Let's do U8 and U8. What else? Hyperdrive rating. Whatever. Max atmosphere. Really costing credits down to cargo capacity. Do U128. U16, because why not? Like, I mean, these are kind of being stupid here I am being stupid on some of these. Whoops. U16. Say, nope, just put a comma. Save. All right. Now let's run this again. Thread main panicked. Request error decode invalid number. Line 1, column 132. Called result unwrap on an error value. Run with rust backtrace equals 1 environment to display the back. Okay. Rust backtrace equals 1. So I'd be willing to bet it didn't convert something properly and pulling it, and so now we're getting issues. There we go. Kind decode source invalid number. Yeah, okay, that's what I just said. Invalid number. So we're getting 10. So credits. Oh, I will bet for length. You know what? I don't want to deal with data types at the moment. Let's just go back to string. I just wanted to see this convert numbers. Okay. So, I mean, we got a good problem. This isn't doing what I expected it to do, and I don't understand why. So let's do some digging. I feel like this should have worked. I feel like this should have, oh, you know what? Thinking about it, it's coming back as a string, so it's going to give us a string, and I was, for some reason, I was kind of playing in my head that it was going to try to convert it into the data type, and I'll bet that doesn't happen. I'll bet that's not a thing. So the question is it worth trying to go down that route or not? Let's not right now, because there's just other areas to go through. So in this case, let's go back to string, and a string. There we go. Okay, let's kill this. So this JSON here is going to return a response of result t JSON errors from here. This isn't telling me kind of what I want to know for sure, so let's just ignore that. Okay, so now let's do our, oops. Copy this. Let's go back over to find here. How can I make this better? Right now, this is something I'm going to do quite a bit. So your current code is already quite good, but there are a few improvements that could be made to enhance the readability. Using async functions with request. I don't really care about that. Handle errors properly. That's what I want to do. Your current code uses unwrap, which will cause your program to panic if the result is an error. Agreed. Instead, you should handle errors gracefully. For example, you could return the error from your main function, which will cause your program to exit with a non-zero status code if your error occurs. This makes it easier to detect and diagnose problems. Remove unnecessary debug trait import since you're not using any debug formatting in your print line, blah, blah, blah. Okay. Makes sense. So I don't want to do async await, or I don't want to do Tokyo. I don't want to do async code. All right. Can you provide an example of number 2 without using Tokyo for async code? Okay, we're going to go do the errors. So deserialize error, use request blocking as. Okay, that's cool. I didn't realize that was a thing in Rust. I should have assumed that it can happen. That's cool. So that's gonna. Oh wait, what? Okay, what I read this as and what I think it is very different. Use request blocking error as request error. Oh my gosh. I read that as like making a request call. Okay. Still makes total sense. Okay. So let response equals request. We're do blocking. We're going to get. Let starship. We're going to get the response dot and then map the error E into. Okay. And then we're going to output starship. In this version of the code, if either get request or JSON parsing fails, the error will be propagated up to the main function. You know, I see this request error, but I'm not seeing it used. This way, if an error occurs, the program will exit a status code. Okay, can you explain further and talk about the question mark? Because I don't remember what the question marks do specifically. And the block that is e.n2 as part of the mapping. So I'm going to make an assumption here reading this. The response.json should normally return to the JSON and it will convert it into a starship. If, however, there is an error, it's going to map the error into some sort of output. That's what I'm guessing. That's what I'm reading this as. So let's see the result that comes out of it. I think this is going to be kind of a fundamental thing to understand is how do we properly deal with errors? Because when I played with Rust in the past, I just do the debug stuff all the time. And I kind of am like, I don't know how to normally do it. And I need to try to figure that out. And so I think this is a good route to, holy crap, that's a lot of text. I do not like this output formatting, Sam I am. Okay, the question mark operator in Rust is used for error propagation. When you append the question mark to an expression, that returns a result. If the result is okay, the value inside is returned. Okay, if the result is an error, the error is returned from the current function immediately. This is known as an early return. Oh, okay, I mean, that makes sense. Okay, let's do a couple follow-up questions. Are there times you would... No, we're going to do two things. Here are a few follow-ups. One, can you give an example of not doing an early return? Two, why would you not do an early return? Okay. What is the Rust idiomatic concepts around, or thoughts? There was a thoughts on early returns. Okay. All right. In your code, we're doing the call. Tries to send a GET request to the URL. If the request is successful, it returns an OK value containing the response. Okay. If the request fails, it returns an error. That's what we just talked about, value containing the error. The question checks the result. If it's okay, it returns the value. The value inside is unwrapped. Okay, so we manually called the unwrap a little bit ago in our code. So here, JSON, we probably, I wonder if we did this. Yeah, that's what we should have done to go ahead and unwrap it. Because now it's implicitly adding the starship here so that it can do it. So let's run this again. There we go. There's our output that we expect. We're learning stuff. I like it. Okay, the EE2 part is a closure that takes an error and converts it into a boxed dynamic error. Box dynamic error. The into method is defined for all types that implement the into trait. Okay. It consumes the value and produces a new value. In this case, it's converting a request error into a box dynamic error. The box dynamic error type is a trait object that can hold any type that implements the error trait. This is useful for returning different types of errors from a function. I mean, that that makes sense. And I think it makes more sense if you understand the box type and probably the dyne error type, probably more like dynamic typing, which I don't understand a lot of on the box type. So that'll be the next question. 4, can you expound a little more on the, trying to use big words and I misspell it, a little more on the box type. Once expounding on the box type, can you add a little more on the dyne error part of box dyne error? So, I mean, so this is kind of making sense, so that if by default what we got is returning an error back, and or by default what was generated for us is going to take a set of errors in that case. So what is there now makes a little more sense. How it actually works, I don't know. So response.j, that's a closure. Then checks the result. If it's okay, the value inside is unwrapped exactly like we expect. If it's error, okay. We're kind of there. I mean, so basically this unwraps the okay, and this unwraps the okay. Otherwise, it's going to push it into an error. Otherwise, this is going to have an error, and it's going to bubble up. I think that's okay. And then I think if I'm right, the result, this right here, is just like, it's not going to have anything. It's like a none return type in a sense from Python. But we'll come back to that. Let's use these follow-ups and see what we get. Oh, wait. What? Oh. Oh. Okay. Crap. Okay. Let's copy. Let rewrite your answer. I mean, I don't have to have GPT-4 for this. All right, I just want. Things are going wrong on the fly. Here we go. All right, cool. Okay. Example of not doing an early return, an alternate to early return is using the match. Okay, the match keyword to handle both okay errors cases explicitly. Here you can, okay. So we're going to do this actually makes a couple things make a little more sense. So we're going to do a request, our get, and we're going to match on the okay, kind of like a switch statement from what I remember. And in that case, it's going to match on doing taking the response and then doing the JSON serialization into Starship. If that is okay, then it's going to print the Starship. If it is not okay, it's going to print the error. If it is not okay from the get, then it's going to fail to send request and pass in that error. That totally makes sense. I get it. Yeah. Cool. I like that. It's good. It's a little wild, the nesting here, but I get what's going on. All right. In this version, the code we're using match to check the result of each operation. If it's okay, we proceed with the next operation. We print the blah, blah, blah. All right. 2, why would you not do an early return? There are several reasons why you might choose not to do an early return. Okay, so before we read more of this, it makes sense doing it this way because if you get an error or you have multiple response types potentially that you need to match on, because in this case it's a simple okay error, but you might have more and you need to match on each of those. And then you might want to do more custom stuff in each of those cases. So makes total sense, but let's see what this says. Complexity. Early return can lead to complex control flow if you have many operations that can fail. In such cases, using match or if let. Interesting. So follow up. Can you provide an example using the if let you discussed? Resource management. If you have resources that need to be cleaned up, whether the function succeeds or fails, so that's what I was saying. You can't use an early return. You'll use a finally block. Okay, yeah. So that's sort of saying if something goes wrong, you want to do extra stuff. There we go. Performance. In some cases, early return can be less efficient. For example, if a function needs to allocate memory or perform other expensive setup tasks, it might be faster to do these once and handle the errors later rather than doing them over and over and over and over again for each operation. Makes sense. Makes sense. All right, now we're going on to see Rust idiomatic thoughts on early returns. In Rust, early returns is considered idiomatic when it simplifies the logic of the function and improves readability. It allows you to avoid deep nesting and makes the success path of the function stand out. However, it's not always the best choice depending on the situation. Makes total sense, which interesting is early return can lead to complex control flow if you have many operations that can fail. I get that, but then it's also early return is considered idiomatic when it simplifies the logic and control flow. Anyway, it's funny. Anyway, explain the box type. The box type is in Rust is a smart pointer that allocates data on the heap rather than the stack. It's used when, man, it's been a long time since I have gone down that rabbit hole. So let's ask for a re-explanation. Okay, can you further dive into allocating data on the heap rather than the stack for a Python developer? Just out of curiosity of what it would give me. All right. It's used when you have large amounts of data that you want to store outside of the current scope, or when you want to transfer ownership of the data across threads or function boundaries. Interesting. Across threads or function. The box type also provides a, hold on. Yep, I meant to open that before this. The box type also provides a fixed size and is stored on the stack, so it can be used in places where only types with a known size can be used. The rest is a smart pointer that allocates data on the heap rather than the stack, but this box type provides a fixed size and is stored on the stack. I feel like those are contradictory statements. So let's ask. It's about storing pointer data on the heap instead of the stack with the box type, but then later say the box type is stored on the stack. Can you explain? What I like about doing this, and I know like this is becoming, you know, chat with AI about learning how to code 101 type stuff, is that this is a conversation I could never have. Like I would have to have someone in person to ask these questions to, and I've never had that available to me for the most part when trying to learn how to code. And it can let me go down some of these rabbit holes that, you know, I would just have to just struggle bust through and try to get to at least a semblance of understanding. And normally that would lead to boilerplate code that I would try to understand later, hopefully. Whereas now I'm actually running down a gamut of things. Some of this I'm still not going to understand, but I'm getting closer to understanding now so that when I can build on it later. And so anyway, excuse me, sorry. So that's why I'm continuing down this path. I'm hoping that this provides value to you, but it also provides value for me while learning. Adding more on the dying error part of the box. The dying error part, okay, the part is a trait object. A trait object represents an instance of a type that implements a certain trait, blah, yeah. In this case, it represents any type that implements the error trait. By using blah, we can handle any type of error, no matter what the concrete type is. This is particularly useful. I feel like this is just re-saying stuff. So I'm not going to dig into that a little more. I'm not going to worry about it. Literally what I just talked about, I'm just going to copy and paste some boilerplate is exactly what I'm going to do in the future. I kind of understand what's going on, so now I can use this, but I'm totally not going to worry about it anymore. Sorry, I'm not going to worry about it right now. I will circle back at a later date when it starts being a blocker. So let's go ahead and hit this and see what happens. Sorry, I had to turn off my heater. It was starting to get a little roasty toasty in here. All right, using the if-let for error handling. The if-let construct is Rust is used for pattern matching. It allows you to execute some code only if a certain pattern matches the value. Okay, so we get the response if let error equals response, print that. If let unwrap.json, do that. So you have to have the debug on that because we're calling unwrap. But we don't have it up. We're not going to analyze that anyway. So I guess it's a specific matching in this example. Like we're specifically So we're trying to, okay, here we go. So we're trying to unwrap what it is. It's going to set it to something. If error is going to be starship, then we're going to do it. Otherwise, we're just going to continue on with starship in this case, or response in this case. Kind of makes sense. I get it. It's another interesting pattern. If the version of the code we're using, if let to check for the result of the operations to error, we print an error message. Blah. Okay. All right. Here's we go. Here's the one where I threw in the little caveat of a Python developer doing heap and stack. Allocating data on the heap rather than the stack. In Python, variables are objects, and the memory of these objects is allocated on the heap. When you create a variable, Python creates an object on the heap, and the variable holds a reference to this object. This is similar to how Rust works with box pointers. When you create a box, Rust allocates memory on the heap and stores the pointer, and this stores the pointer to this memory on the stack. The box itself is a small fixed size piece. That did not give me that did not give me the answer that I wanted. And I'm willing to bet number 3 is going to be a rewrite of number 2, because of course it is. And, I mean, it makes sense. I didn't do a good job asking the question. Let's ask more details here in a second. All right, the box type in Rust is indeed a smart pointer that allocates data. However, the box pointer itself is also data, and it must be stored somewhere. In Rust, data is stored on the stack whenever possible, because the stack allocation is faster and doesn't require manual memory management. Therefore, even though the data pointer by the box is stored on the heap. Okay. No, what? Crap. It's not what I wanted. Auto suggest. Can I stop? Just stop generating. Okay. With memory management. This is the last time I'm going to go on this one, because like I am not that detailed into Rust right now that I'm concerned about this, but I'm going to give it one shot and then we're going to move on. Memory management, what is the difference between the heap and the stack? And this is totally like, it's been years since I have even looked at heap versus stack stuff. All right, the stack and the heap are 2 regions of memory. That's kind of what I remember. Used for different purpose. Stack memory is used for static memory allocation. That means the memory is allocated and deallocated. The heap memory is used for dynamic memory allocation. That means memory is allocated and deallocated based on runtime. Okay, that makes, so if you have a fixed size of a thing, of a data structure, so you want to pre-allocate, so like in 32, you're pre-allocating the amount of space on the in memory that you want, and so that's going to go on the stack. When you have a dynamic setup like the box, in this case like the box, is going to put it on the heap, because that's where it's going to dynamically change size. The size of the heap memory is not fixed. It can grow and shrink during runtime. Heap memory is slower because it's got to allocate stuff. Yeah. The downside is that you have to manage heap memory yourself. You have to allocate it when you need it, and remember to free it up. Rust is not like that, as I understand it, and solves that problem. That's where the borrow checker comes in, and it provides pain. The downside is that stack memory is limited in size. You have to try to use more stack memory than is available. You'll get stack overflow errors. That makes sense. Stack memory is automatically managed by the system, meaning you don't have to worry about freeing it when you're done. However, you can't manually control where in the stack memory gets. Okay, that makes a lot more sense. We're going to stop going down that particular rabbit hole, because I don't feel like we're getting any value from heap and stack. I feel like we're getting a little better understanding on the return types and how to deal with them. We can use the unwrap with the debug. We use the question mark to automatically return back the result set and set that. Otherwise, We have to manage the error. We can use match to deal with errors. I feel like we're getting a little further in understanding, and we're going to be able to write a little bit better software. So let us move on to another example. And in this case, let's do just a couple dumb little things here. Let's write a couple of different functions and then call it from a main function. Let's just expand a little bit and see how things go. So I'm going to take this. I want to paste this up here. And all right. And now I want to function get starship. So here's the cool thing about using AI. So get starship, pass it in an ID. And this is what's going to kill me is because I'm using it. It's going to help me with borrow checking and all of that, like all the memory management stuff. And I'm going to trust that it works. And it's going to bite me at some point, and I'm going to be super annoyed. But let's see what happens. All right. So we're gonna format it. Interesting. Creates a string using interpolation. Okay. To get it. Oh, okay. I get what it's doing. We're gonna pass the ID that we passed in up here. It's gonna be a string ID that we're gonna put inside of there. Cool. Let response start. So we're gonna do the request from the URL that we're doing. Then we're going to unwrap it if we're good. We're going to convert it to JSON and then unwrap it, set it to response. Then we're expecting a result, and we want what's inside of the OK result to be returned. In this case, we're expecting a starship, which is that, and we're expecting a box of errors. Oh my gosh. Is that done on purpose? Like, is that on purpose, or is that a kind of like a happy coincidence, a box of errors? Okay, I'm gonna stop being dumb. I don't know why I find that so funny. All right, so we have our get starship method. Let's delete this. No, we're not gonna delete that. Yeah, so remember when I was talking to the return result, we're expecting kind of an empty, a none or whatever, and we're doing, that makes a lot more. So I think we kind of went down the OK and the result path, and I'm getting a little better understanding of what's going on. So let's do a nice, except I want to do 2, and I don't want to do rest, but I want to do ship 1. Cool. And I'll let ship 2. Cool, but let's do 9. So we're going to do that, and then ship 1 and ship 2. There we go. All right, so let's talk about this real quick. So we're going to get a starship. It's going to set it to ship 1. We're going to get a starship, set it to ship 2. Here we're doing our unwrap of the OK result, and we're setting it to ship 1 and ship 2. That is making 1,000 times % more clear than what I've ever had in the past. I really hope that y'all are seeing my code right now, and I'm going to be really annoyed if I go to check this later. Like, I just have this like uncontrollable feeling that it's not what it's supposed to be at the moment. Anyway, let's keep going. So we have ship 1, ship 2, getting in there, and then I think we're good. Let's try to run it. Cargo run. Sweet, it worked. So to make this a little easier, let's use some dot notation and just do name and name. There we go. Cargo run it. There we go. A CR-90 Corvette and the Death Star. Nice. If you don't see my eyes going directly there, it's because I'm looking at a little monitor over here. I'm trying to remember to look directly at the lens and not the monitor, because I don't like it when people look at the monitor. I like it when they look right at the lens. So anyway, enough about that. Very cool. All right. So now we've created a couple of functions. We understand calling other stuff, getting the result back, returning that, and setting it. So now let's do something that's a little more interesting that could get us in trouble. All right, let's do function. And I'm not going to let the AI do this. I'm going to try not to. Function print starship. And I want to pass it in a ship starship. I did not look at anything in there because I don't want to have that be an issue. So let's just do, I didn't want it to taint what I was doing. So let's do ship, and we'll do dot, what's available to us? Ooh. Oh, no, put the dot in the wrong place. Dot, crew. Let's do dot crew just to do it. All right, now we're going to do print starship 1, 2, and all that. And set up, we need some of that. Boom. All right, now let's cargo run. Cool. We got our size, and then we got the Death Star and the quantity of crew that it can have. I think we are moving on. So I know this is stupid and mundane, but I kind of was wanting to play with, how do you call, calling other functions, setting up a couple of things, and seeing what we get back. So I think with that, I think we're kind of done with kind of messing with doing an API. I kind of want to do some other stuff to learn, but what else can we do with this? Is there anything with the data? No. Here's an idea. Let's get a random one and handle 404s. Yeah, let's do that. So another thing is I want to handle a 404. And in this case, if we do, let's go ahead. We're going to kill that one. Kill that one. Let's just rename this to that. Let's do that. So I want to, let's go ahead and run this. It should blow up. Yeah. Missing field name. Okay. So that's because we are getting a 404 because it is not there. I would not know how to handle this. So like learning from scratch, like, wow, I'm getting a 404. How do I approach solving that problem? First, I want to do something. Let's try to solve it manually for the next couple of minutes instead, and then let's do it through AI and see what the result we get. All right. I need to handle a 404 in an idiomatic Rust way, doing a request. Can you provide an example based on this function? There we go. We are not going to look at that. Let's go and look at the request library. Request. So it's easy to jump to code. I mean, to AI and kind of just get the result. And that's actually, in this early of learning, not necessarily a bad idea, because it adds unnecessary complexity. And once you start seeing patterns of how a bunch of stuff works, you can start like melding those patterns together. The key is, after you copy and paste enough, you need to start writing it from scratch as well. And I'm still in the try to find an example, copy, paste, and then as I see the pattern enough, I'll eventually start to be able to write it myself, which is the ultimate goal. All right, so let's do 404. Ooh, response status. Okay. Request error is stat return. Nope. Error. Okay, here we go. The response we're getting in, response if is redirect. Okay. Okay. What if I want, is stat, I don't know what this is status is. Status returns the status code if the error generated. Let's look at this. So status, match, kind status, some status. Okay. Returns the status code if error was generated from a response. So I feel like this would return the 404 option, Cornium option is yeah. This is like like this is going over my head. Crap. Digging deep here. Okay. So if I'm getting an error, so here we are getting the response. I am going to click on here and then scroll up without looking at, I didn't look at any of the code. If error E, let's try. So if we look at this code, error E print line, we're going to that. Let's try this. Copy, actually, yeah. URL, so we go response, Control V. Response. So that does an unwrap of the starship. Let's see if response dot oh man, oh I used Copilot bailed me out. Okay. Okay. I was spoiled. I was spoiled. I was trying to do this without AI. And Copilot saved my rear end here. Okay. So let's go ahead and look at it. So we're doing if let error. We're getting a response type. We're letting the response equal a thing. If the error status code. So see, let's look at unwrap. See, panics to value isn't okay with a custom panic error message. Panics with a 2 returns the contained error value consuming the self. Okay, I guess this is like the unwrap, except it's unwrapping the error. But I don't know the return type in this case. Result, error, but then has a status attached to it, which is the status code from the response, the request response. And then we unwrap the OK from that. And if that is a 404, then we want to print the error out of Starship not found. Otherwise, we do that. In this case, we are doing that. Okay, in this case, we're still not out of the woods yet. So we're doing that. So that gets us, and then we're doing the check. Then we're doing the let Starship equal. I am not looking at the generated code that just happened. So let the Starship equal response. And then, so I just did the question mark to unwrap it. So we get the result back from that. So then we want to do, so we're going to do .json. And then we want to cast that to a Starship. Okay, oh, I was on the right track. So that should cast it to our Starship struct, but then we want to return that because we're expecting a result type. So we're going to do that. And this is where it all falls apart. I feel like I have totally, I feel like I got further, but I don't feel like this is right because error. You can't return a none. So this should return. So what if we returned an E? Return E? Does that work? Expected E result enum error E. Yeah, I don't know what it should be. Okay. I feel like I got a little further. I still have things to figure out. Let's scroll all the way down and look at the result of this. Okay. Format that. We're going to do our request. It's going to unwrap it. If oh my gosh. That's so, sorry. This part is easier. Okay. I guess that makes sense. I mean, let's reapproach here. So if the response, wait, what? If response dot, I need to look up what the bang is. Status is success. Oh, not, oh my gosh. So if not success, then we're going to return an error. Okay, I'm not going to look up all that stuff, but we're returning an error like we're expecting up there. Otherwise, we should be able to do our thing here. So we're getting our response. We're unwrapping it. Okay, I feel like that's probably, I mean, this is, oh, okay, response.status as U16, and then we're getting the URL that we called. I like that better than this. I mean, I get that one because it's going to do the same thing. Let's just leave it. Let's just leave it. Competing AIs. All right. Response.json. Okay. Yeah. Starship. There we go. Yep. I get it. Or not. I might not get it. I might be terrible. We've got to unwrap the good result. Response.json. Something is not happy here. On the get, okay. Okay, yeah. So we're unpacking the good result here. Then we're returning that. So we're getting the response object. Then we're saying, hey, as part of the response object, we're getting the status. We're checking to make sure it's a success. If it's not a success, we're going to go ahead and return an error. We're going to format a message to it, getting the response.status. And it's going to convert it into whatever we're expecting. And then we are unpacking the response JSON, getting the result from that. That's going to convert it to a Starship. And then we're returning a result of Starship packed into the OK because we're expecting a result type. And then we're going to return back up here, ship, and then we're going to print it. I think we are on our way. Cargo run. Error 404 not found. Okay. So let's go ahead and change this to a 2 because we know that works. And we're going to run this one. And there we go. We got it. We got our CR90 Corvette and our crew size. I think that's it. I think we have successfully figured a few things out. Again, this was another rabbit hole, but I think it was a good rabbit hole. We discussed going through the return types. We figured out result. We figured out unpacking and unwrapping and how that works, kind of returning some of that. We used AI to generate our struct for us. We learned a little more on the debug with unwrapping. Learn a little more on deserializing with JSON and the response. We successfully-ish, successfully as in the code is working. Got a little closer in trying to figure out how to deal with handling errors and stuff. I think a big one is returning a proper result type for a function. That one, I'm glad I understand that a lot better now. One of the interesting things on this is that Starship here, crap, I totally lost where I was going. Sorry, I lost it. Anyway, if I remember next time, I will let you know. But I think this was a great start. I think we're making progress. I was a little hesitant about where we were going to go, but I think we are probably done with the Star Wars API right now. And next week we'll move into another project, and I want to start dealing with passing data around and dealing with mutating types and immutable types, and working with that in Rust, because I feel like that's an important thing to figure out. And I feel like that's going to probably, I don't know, I might figure it out the first time and with some of the examples I want to do. But I want to figure that out. I think with this alone, we're able to call the YouTube API, because remember last week I talked about the project that I want to do. I think we can call the YouTube API, get the results that we want, and print it out to the command line. Another thing I want to figure out is what is more the proper way to write stuff out to command line than doing this print line with the debug information. But again, that's another day. I think we're doing good. I think we're on track on learning. I think these are some of the good basics that a developer that is experienced with developing but new to Rust, I think this is a good track to go down if you know some of the basics of Rust. So anyway, with that, I want to thank you for your time. I want to thank you for watching. Hopefully you learned something. Go ahead and leave me a comment, like, and subscribe if you would, so that I can know people are interested. And with that in mind, I thank you for your time, and I'll see you next time.